So now that we've created our project, it's time to run it. In this video we're going to talk about how to do this on a command line. This has a couple of benefits actually, where via Cradle you can run and package your application on a command line, which means you can also do that on a continuous integration server like Jenkins. So let's see how we can actually achieve this. First, open up the terminal. On Linux and Mac OS X, that's pretty easy to do. On Windows, you want to open up the command shell, which is cmd.exe. Once you have your command open, make sure you actually have this path environment variable set, which is Android home, which points at your Android SDK installation directory. You can set this on Windows via saying Android home equals and then your path to your SDK directory. On Linux and Mac OS X, it's the same thing, pretty much. Once all of this is configured, you can go to your project's root directory, and then you can just execute Cradle in here. To execute Cradle, you have to use one of these two scripts, depending on the operating system you're on. On Linux and Mac OS X, Cradle W will be your friend, which is just a shell script basically. That will invoke Cradle itself. And on Windows, you want to execute cradlew.bat, which is the batch file. So since I'm on Mac OS X, we're going to use the Mac Unix version of this command. So let's do cradlew, and then we can say tasks. This will list all the tasks that are available. What is a task? A task is basically a command you give to Cradle that it can execute for you. Common tasks are compilation tasks or running tasks or cleaning tasks and so on and so forth. As you can see, there's quite a lot of tasks here. There's even more if you ask for the tasks for a specific project. I would suggest that you look through our wiki, which has all the relevant tasks listed, which is going to look at the tasks that run the application on different platforms. So, as we saw earlier, the structure of our project is a little peculiar if you're not used to multi-project setups. Let's just walk through it one more time. We have the core project, which contains all of our code. In this case, it's just a simple application really that come on, open it up, that loads a texture and then clears the screen and draws the texture all the time. You saw that the texture we reference is actually a file called badlogic.jpg, so where are our asset files? The asset files are usually in the Android project's assets directory. So if you run an application, it will be run relative to this directory on a desktop, and then you can just reference your assets like this. This is also true for all the other platforms. If you don't have an Android project, the assets directory will most likely be in your core or your desktop directory. So what are the other projects for? Well, for each platform you need a launcher class, so to speak. So on Android we want to run our game, but for that we can just say, hey game, run yourself on Android, but we have to write something called a launcher class. On Android it looks like this. It's an Android application. It does some setup, it creates a configuration, and then it initializes itself using our libGDX game class to run the application. The same is true for all the other platforms. So if you look at the desktop, we also have a very simple launcher class, which looks like this. It's just a public static main method, creates a LWJGL application configuration, and then an application, which we hand over our game and the configuration, and it will run on a desktop. The concept is the same for the HTML and iOS platforms. I will spare you the details here. You can just browse the folder structure. Okay, so now that we know how our project is structured, let's see how we can run it. Let's try running it on a desktop first. For this we have to invoke the desktop project, and we have a Cradle task that will launch your application on the desktop. So you just go cradlew desktop :run, and this will run your application on the desktop. What this does is it compiles the application to a jar. It also packages the assets into that jar and will then just invoke the jar file. The desktop launcher class will be the main class, as you can see here. If you're super crazy, you can of course just open up your core class and modify, say, the clearing color. Let's say we make it yellow. Oopsie. Let's make it yellow and rerun our application. This will recompile all that has changed, package it up again, and run our application. As you can see, this process isn't immediate. That's just because Gradle apparently still has problems with incremental compilation and also parsing all the Gradle build files. So now we have our application running with a yellow background color. So you run it on a desktop. GradleW desktop :run. To run it on Android, you basically do the same. You say Android, and then you use either install debug, which will create a debug APK that is not signed, and install it to a connected emulator or device, or you can use install release, which will package your application for Android, sign it, and then install it on a connected device or emulator. I'm not going to do this in this video because firing up the emulator takes some time, and running it on a device is pretty useless because you won't see it. Suffice it to say, you shouldn't use the emulator because it's bad. Always test on a real device. The emulator has kind of broken OpenGL support, and it's not representative of the real performance of your application on Android. So then let's move on to the next target. Let's run it on iOS. So as you might have imagined, it's basically specifying iOS and then using one of these three tasks here. So you can either launch it on a connected device, launch it on an iPad simulator, or launch it on an iPhone simulator. For the demonstration purposes here, we're going to launch it on an iPhone simulator. So we just type iPhone simulator. And this will compile your application for iOS, that is for the iOS simulator. It will take not only your code, but it will also take the code of RoboVM, which is what we use to run Java or any other JVM language on iOS. And that means that we have to compile, on the first try, all of RoboVM's class libraries. That is about 3,000 files that need to be compiled to native code. As you can imagine, that takes a little bit, but this process only needs to be done once. And on the next compile, RoboVM is smart enough to only compile the classes that actually changed. Then it's just a matter of seconds until the application is actually done. So I did this previously, so the startup is a little faster. And now you can see our application starting up on the iOS simulator. You can either close the simulator or leave it open and then just kill your Gradle task here via Control-C. I would suggest leaving the simulator open because it takes a little while for it to start. Not as much as the Android emulator, but still. Okay, so the last thing we want to look at is launching application for HTML5. And this is, again, pretty easy to do. You just invoke Gradle again, and then you specify the HTML target and say superdev. Now, this will make Gradle compile your application to JavaScript via Quid, the Google Web Toolkit. It will also package up all the assets and your image files, audio files, also the index.html and CSS files that come with your standard Gradle project setup. And if all of that is compiled, it will actually start up a server, which will serve your static assets, the JavaScript and HTML and image files. So you can test it locally in your browser, which we're going to open up here. Oops. And it will start up a second server, which actually allows you to click a little button here in the browser and recompile your code. That is actually pretty neat. And we're going to see how that works in a minute. As you can see, compiling GWT takes a little while. That's just the GWT compiler being really slow. But thankfully, we don't have to do this all the time. So now you see the code server is ready, which means we can go to localhost 8080/HTML. And there we have our application running as a pure JavaScript application in your browser. Now, I told you you don't have to recompile. What we can actually do is we can go to our code file. No, it doesn't work like this. Okay. We can open up our little main class and change the background color back to red, and then click on superdev refresh and compile. And what this does is it actually tells the server in the background to recompile our application and then reload the application in the browser, which is pretty neat. What you can also do is you can debug your Java code directly in the browser. Just right-click and go to Inspect Element in Chrome or similar tools in Firefox. And then you go to Sources, and then you can navigate your way to your game's source code. In this case, our source code is a single class file, so there's not a lot of code to look at, but as you can see, we can actually set breakpoints, we can step, and we can inspect local variables and all of that good stuff. So speaking of debugging, how do we debug the other things? With the command line way of doing things, you can actually not debug any of the other applications. You could, in theory, debug the desktop version of your app via GDB, which is a command line Java debugger. I would not recommend doing that though. So if you have to debug something real quick, you could actually just use the browser version. If you need something more sophisticated, I would suggest you look into doing it with the IDE. Okay, so now that we've seen how we run our application on the command line, it's time to package our application, for which there's a separate video, which is linked to at the end of this video.